Now let's study Doppler effect in sound. The apparent change in the frequency of the source due to a relative motion between the source and the observer is known as Doppler effect. Let's see case 1. When sound source is moving and observer is stationary, let the source is emitting n waves per second. If the source is stationary, then these n waves will spread in the distance v, so lambda equal to v upon n. But since source is moving, so in 1 second distance covered by the source is Vs, so n waves will now spread in distance V minus Vs. So we can write lambda dash equal to V minus Vs upon n, where lambda dash is the apparent wavelength. So apparent frequency n dash equal to V upon lambda dash equal to V upon V minus Vs into n. So n dash is more than n and lambda dash is less than lambda. Always remember, apparent wavelength will change only when source will move. If source is not moving, then apparent wavelength will not change at all. Now let's see the case 2. When observer is moving and source is stationary, let source is emitting n waves per second and observer speed is v naught. So we can write n dash equal to n plus v naught upon lambda, which is equal to n plus v naught upon v into n. So n dash equal to n v plus v naught upon v, and lambda dash in this situation will be equal to lambda. Now let's see case 3. Figure shows that both source and observer are moving towards each other with speeds Vs and V naught respectively, and V is the speed of sound. Imagine that if only source were moving, then the apparent frequency heard by observer would be n1 equal to V upon V minus Vs into n. Since observer is also moving, so n dash equal to V plus V naught upon V into n1. So n dash equal to V plus Vo upon V minus Vs into n. This is the apparent frequency.